Imagine an invisible shield deflecting harm like an impenetrable wall. Sounds like science fiction, right? But what if such a shield, a force field, could be real? The idea has captivated scientists and storytellers alike, fueling our imagination for generations. Could we one day harness the power to manipulate forces and create an invisible armor? The quest to understand and control forces is a fundamental human pursuit. From the earliest tools to modern technology, we strive to manipulate our environment. Force fields, in their purest form, represent the ultimate control over our surroundings, a way to interact with the world without physically touching it. But how close are we to turning this dream into reality? Force fields, in the simplest terms, are regions of space where forces interact to create a barrier. This barrier can repel matter or energy, effectively acting as a shield. Imagine a wall that you can't see or touch, yet it stops objects in their tracks. That's the basic concept of a force field. These fields aren't always about stopping things. They can also be used to confine or manipulate objects. Think of a tractor beam from Star Trek trapping an enemy ship. This too is a form of force field, using focused energy to control movement. Force fields are often depicted as shimmering walls of energy, but their actual appearance would depend on the forces involved. Some might be invisible, while others could manifest as glowing barriers or shimmering distortions of space. Believe it or not, we live with a force field every day. Earth's magnetic field, this invisible shield, protects us from harmful solar radiation, deflecting charged particles streaming from the sun. The Earth's core, a swirling mass of molten iron, generates this magnetic field. It acts as a giant bar magnet, with lines of magnetic force extending from the South Pole to the North Pole. These lines create a protective bubble around our planet, deflecting the constant bombardment of solar wind. Without this natural force field, life on Earth as we know it wouldn't be possible. Science fiction has long embraced the concept of force fields, using them to protect spaceships, create impenetrable barriers, and even as weapons. From the iconic deflector shields of Star Wars to the shimmering force fields of Star Trek, these imaginary barriers have fueled our imagination for decades. In these fictional universes, force fields are often portrayed as impenetrable barriers, capable of stopping energy blasts and physical projectiles with equal ease. While the science behind these fictional shields is often loosely defined or entirely absent, they nevertheless capture our imagination and inspire us to explore the possibilities of manipulating forces. Section 5, real-world deflectors, plasma windows and beyond. While we haven't quite reached the level of Star Wars or Star Trek, real-world science is making strides towards developing force field technology. The idea of creating barriers that can protect us from various threats has long been a staple of science fiction, but now it's inching closer to reality. One promising avenue is the plasma window, a technology that uses a thin layer of superheated gas or plasma to create a barrier. This barrier is not just a theoretical concept, it has been demonstrated in laboratory settings with impressive results. These plasma windows can be incredibly strong for their thickness, capable of withstanding extreme temperatures and pressures. Imagine a barrier that is almost invisible yet can stop high-speed particles or withstand the heat of a furnace. While still in the early stages of development, plasma windows have potential applications in various fields, from protecting spacecraft from micrometeoroids. This could revolutionize space travel, making it safer and more efficient, to creating more efficient industrial furnaces. In manufacturing, these plasma windows could lead to significant advancements, allowing for higher temperatures and more controlled environments. Another area of research focuses on using electromagnetic fields to manipulate and control objects. This technology is not just about moving objects, it has the potential to change how we interact with the physical world. Scientists have successfully levitated small objects using carefully controlled magnetic fields, showcasing the possibilities of non-contact manipulation, demonstrating the potential for using forces to manipulate matter without physical contact. This could lead to innovations in various industries, from manufacturing to medical technology, where precision and control are paramount. Section 6, the science of repulsion, how force fields could work. The fundamental principle behind force fields lies in manipulating the four fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces. These forces govern the interactions of all matter and energy in the universe, and by mastering them, we could unlock incredible technological advancements. By understanding and controlling these forces, we could theoretically create barriers that repel matter or energy. Imagine a shield that could protect against physical attacks or harmful radiation, effectively creating a protective bubble around an object or area. Electromagnetism, the force that governs the interaction of electrically charged particles, holds the most promise for creating large-scale force fields. This force is already harnessed in technologies like MRI machines and particle accelerators, showing its potential for more advanced applications. By generating powerful and precisely controlled electromagnetic fields, it might be possible to deflect projectiles, manipulate objects, and even create barriers that can withstand extreme temperatures and pressures. Such force fields could revolutionize defense systems, space travel, and even everyday safety measures. Harnessing the other fundamental forces, such as gravity or the nuclear forces, presents even greater challenges. Gravity, for instance, is a weak force compared to electromagnetism, making it harder to manipulate on a small scale. However, the potential applications, such as creating anti-gravity fields, are tantalizing. However, advances in our understanding of these forces could one day unlock new possibilities for force field technology. As our knowledge of quantum mechanics and particle physics grows, so too does our ability to manipulate the very fabric of reality, bringing the dream of force fields closer to reality. The future of force field technology is not just a matter of if, but when. Section 7. A future fortified applications across industries. The potential applications of force field technology are vast and varied, spanning numerous industries and aspects of our lives. In space exploration, force fields could protect spacecraft from micrometeoroids and radiation, making space travel safer and more efficient. In construction and engineering, force fields could be used to create temporary barriers, protecting workers from hazards or facilitating construction in more challenging environments. Imagine building bridges in earthquake-prone areas or constructing underwater structures with the help of force fields. Force field technology could also revolutionize safety and security. Imagine force fields protecting buildings from explosions, vehicles from collisions, or even creating invisible barriers to control crowds or secure sensitive areas. Section 8. The hurdles ahead. Challenges in force field technology. While the concept of force fields is alluring, numerous challenges stand in the way of realizing their full potential. One of the biggest hurdles is the sheer amount of energy required to generate and maintain a force field, especially on a large scale. Another challenge lies in controlling and shaping these fields with precision. Creating a force field that can selectively block certain types of matter or energy while allowing others to pass through requires an extremely sophisticated understanding and control of forces. Furthermore, the materials and technologies required to generate and manipulate these forces on a practical scale are still under development. Overcoming these challenges will require significant advancements in materials science, energy storage, and our understanding of fundamental physics. Section 9. Through the Looking Glass, a future guarded by the unseen. Despite the challenges, the pursuit of force field technology offers a glimpse into a future where we can manipulate the very fabric of space and time. This technology, still in its infancy, holds the promise of revolutionizing our world in ways we can barely imagine today. Imagine a world where invisible barriers protect our cities from natural disasters, where hurricanes and earthquakes are no longer a threat to our urban landscapes. These force fields could act as a shield, absorbing and deflecting the immense energy of natural calamities. Picture spacecraft traversing the cosmos, shielded from harm by energy barriers that repel space debris and cosmic radiation. This would open up new frontiers in space exploration, making long-duration missions safer and more feasible. In the realm of defense, imagine a world where the destructive power of weapons is rendered obsolete by impenetrable shields. These energy barriers could protect soldiers and civilians alike, reducing the devastation of warfare and saving countless lives. While such a future may seem like the stuff of science fiction, the journey of scientific discovery is often stranger than fiction. The advancements we make today lay the groundwork for the seemingly impossible achievements of tomorrow. The journey of scientific discovery is often stranger than fiction. The pursuit of force field technology, driven by our insatiable curiosity and desire to explore the unknown, is a testament to human ingenuity and perseverance. The pursuit of force field technology, driven by our insatiable curiosity and desire to explore the unknown, could one day lead us to a future where the impossible becomes possible. Researchers are tirelessly working on prototypes and experiments that push the boundaries of what we know. Could one day lead us to a future where the impossible becomes possible. What will we build, explore, and protect when we unlock the secrets of the unseen shields? The possibilities are endless, and the potential impact on our world is profound. What will we build, explore, and protect when we unlock the secrets of the unseen shields? The future is a canvas, and with force field technology we have the potential to paint a world that is safer, more resilient, and filled with new opportunities for exploration and discovery. Gap 3S Section 10, The Ethical Dilemmas of an Invisible Shield. As we stand on the cusp of a future guarded by the unseen, it is imperative to consider the ethical implications of force field technology. While the potential benefits are immense, the advent of such powerful technology also brings forth significant moral and societal questions. Imagine a world where only the wealthy and powerful have access to force field technology, creating an even wider gap between the rich and the poor. These invisible shields could become tools of oppression, allowing those in power to fortify their positions and protect their interests while leaving the vulnerable unprotected. This could lead to a society where inequality is not only prevalent but also physically reinforced by technology. Moreover, in the realm of warfare, the development of impenetrable shields could lead to an arms race of unprecedented proportions. Nations might invest heavily in force field technology to gain a strategic advantage, potentially escalating global tensions and leading to an era of perpetual conflict. The question arises, should such technology be regulated? And if so, how can we ensure it is used ethically and responsibly? The environmental impact of force field technology is another crucial consideration. The energy required to generate and maintain these fields could be immense, potentially leading to increased resource consumption and environmental degradation. As we pursue these technological advancements, we must also strive for sustainable and eco-friendly solutions. In the realm of privacy, the ability to create invisible barriers could be misused to invade personal spaces or restrict freedom of movement. The potential for abuse is significant, and it is essential to establish clear guidelines and regulations to protect individual rights and freedoms. As we venture into this new frontier, it is crucial to engage in thoughtful and inclusive discussions about the ethical use of force field technology. Policymakers, scientists, ethicists, and the public must come together to navigate these complex issues and ensure that this powerful technology is harnessed for the greater good. In conclusion, the pursuit of force field technology is a testament to human ingenuity and our relentless drive to explore the unknown. However, with great power comes great responsibility. As we unlock the secrets of the unseen shields, let us also commit to using this knowledge wisely and ethically, creating a future that is not only safer and more resilient, but also just and equitable for all. Gap 3S, thank you for joining us on this journey through the fascinating world of force fields. Until next time, stay curious and keep exploring.